Hi guys, today we'll continue with our lecture. Today we'll study about methods or measures of dispersion, and we'll continue building upon central tendencies. So just a quick recap, we studied central tendency, that is mean, mode and median. And the whole idea of studying those central tendencies was that if someone asks or wants to know how the data set looks, and the data set contains a million values, that person has no time to understand those million values. You're quickly able to give them some numbers that describe this very well. We already know how mean, mode, and median describe these. Let us talk about range, interquartile range, variation, and standard deviation. Okay. The first thing that we need to understand for range is the range is minimum value and maximum value, the difference between those. Okay. Let's see how it is different. Let's say the numbers are 2, 3, and 4, and I'm taking smaller set, but you can always replicate this in larger set as well. Okay. And 0, 3, and so just let me give me a quick message. 6. Okay. Now both the mean and the median would come out to be 3. But the minimum and maximum value, the range is 2, and the range here is 6. Okay. So if you say mean mode is 3 and the range is 6, so you can see, or mean mode is 3 and the range is 2. You can slightly understand that how these two data set differs. Okay, this becomes a range, difference between a minimum and maximum range. Before we start to understand what is interquartile range, let's understand what is percentile. Okay, so if there are 100 elements, okay, and these 100 elements are sorted, then the 100th element is the 100th percentile, the 99th element is the 99th percentile, 98th element is 98th percentile, and so on. 10th element is known as 10th percentile or decile or something like that. You might have heard somebody scored 99 percentile in CAT exam. Okay, that means 99% of the people had less marks than him. Okay, so 99 percentile means 99% of all the other values are less than this. Okay, so interquartile range becomes 25th quartile percentage, 75th percentile. Okay, so minimum and maximum sometimes, if you remember, can have outlier effect. So we, in order to ignore them, we do this. I'll quickly give you another example. Okay, that if I add a large value at this end, the range would increase, but just one value would increase the range. So range is susceptible to outliers. Okay, it gets affected by outlier. Interquartile range does not get affected by outliers. Hence, people use that. Okay. The most used methods are variation and standard deviation, where they're essentially the same. It's just that standard deviation is equal to variance. Okay. So if I do under root variance, I would get standard deviation. Okay. Now, for understanding this, let's quickly understand the formula for variance. So variance formula would be mu minus x, sigma x is equal to 0, x upon n whole upon n. Okay, so you basically, what are you doing? You're taking x minus mu, sorry. So let me write it down again. Variance is equal to sigma n is equal to 0 to n is equal to n, x is equal to 0 essentially, where you're doing x minus mu, and okay. Now what you need to understand here is that this essentially is a great measure of understanding dispersion. Okay, why? Because if you see, I am basically finding how far each element is from the mean. Okay, x minus mu would give me what on this, like for example, one element is 2 and the mean is 4, the difference. Okay, each difference, sometimes element will be on right side because I'm doing square, so the issue of sign is negated. Okay, so if the mean is 4 and one element is 2 and one element is 6, the difference is 2. You square that, difference is 2 and minus 2. If you square it, it becomes 4 and 4. So this creates the problem, solves the problem. Okay, and number of elements. So basically what how far each element is from the mean, average of that. Since you're squaring it to get the sign accurate, you have to do under root as well when you look for standard deviation, but in variation you do not. Okay, so this becomes variation. If you do underscore of variation, under root of variation, you would get standard deviation. Why do you do it? Because you've already squared the term to disinclude the issue of signs. These are very important things, uh, and mostly these are the ones used, that each element is taken into account. Since each element is taken into account, they are not susceptible to outliers as well. Okay. Now, why do you read this measures of dispersion? Okay. A again. So if you remember, if you see, there is a large difference between the range and the percentiles or the interquartile range. You can figure out that there is anomaly or an outlier. Okay, that's one thing. Okay, if you see that the variation is extremely high, you know that the data goes like this. Okay, but if the variation is less, the data is very stable and very concentrated near the mean. If this is the line of mean. Okay, so from here the variation is very less, here the variation is very high. You can see this is the line of mean, and the data point is here and here. It's too far, it varies a lot. So the mean might be same, but the variation is changing. So you might sometimes know for a fact that there are certain transformation that is needed. Okay. You might also sometimes know that there is normalization needed. Why? Because the range would help you see that you can do 0 to 1 normalization via using range. We will study this in detail about in transformation chapters. Feature selection we'll study in detail in machine learning chapter, and transformation in transformation again. But what you really need to understand is that if you see all these concepts of dispersions, these can help you understand in quick terminology how the data is distributed. So if I know the mean, the median, the minimum value, the maximum value, and the quartile ranges, that is 25 and 75, the interquartile range, or these values, essentially, I can guarantee you that it doesn't matter how many values are there, I can give you an accurate description of it, or I can understand data completely. Also remember, median is 50th percentile. Just a quick reminder, because again, 50% means the middle value. So median becomes the 50th percentile. So that's why it is used here. And what we're going to do is quickly, we'll also talk about assignment. And there is a small assignment, like for example, this is an example, do using paper and pen. So you should calculate the variance using paper and pen, no calculator. Just because once you do it, I understand you have to do under root and all sometimes, like you have to do square and all, and it's tedious. But if you do it via pen and pencil one time, you'll always remember the formula. There is no way you will forget the formula. And assignment is that you need to collect weight, height, and gender samples of 30 individuals around you, and measure central tendency, dispersion, and see if there's any shift in central tendency. If yes, then why. Just quick assignment, do it on your own, and it's going to help you basically totally understand. And if you discover things like that, I'm guaranteeing you, if you do this right, you would remember the concept and actually understand them, how to use them. That will be all, and we'll see you in the next lecture. Thank you, guys.